Welcome to aminacademy.com. In engineering thermodynamics, let us discuss about thermodynamic systems. Look at this figure, piston and cylinder. Here, this cylinder is surrounding. Inside a piston and cylinder is called a system, thermodynamic system. A thermodynamic system is defined as a quantity of matter or a region in space that is of interest. Here, suppose here inside you are considering it's a system. The mass or region outside the system is called the surroundings. And the surface that separates the system and the surroundings is called the boundary. Here, this is the boundary here. Therefore, a system is a finite quantity of matter or prescribed region of space. Now, further detail about thermodynamic system and its types. A system that is from the surroundings by real or hypothetical boundaries is known as a thermodynamic system. That means a system that is delimited from the surroundings by real or hypothetical boundaries is known as the thermodynamic system. A thermodynamic system refers to that of the universe in which observation are made and the remaining universe constitutes the surroundings. The surroundings contain everything other than the system. The system and the surroundings together make up the universe. Suppose we consider all the universe, that is, the universe is equal the system plus surroundings. Thermodynamic system is embedded in its environment or surroundings, through which it can exchange heat with and do work on. It exchanges the heat to its surroundings through a boundary. The boundary is the wall that separates the system and the environment. The thermodynamic system can exchange energy or matter with external environment and can also undergo internal transformations. Now, look at this figure. Here, this is an isolated system, completely isolated from the surroundings. Here, the closed system. Here, the open system. Thermodynamic system is physical entity with a defined boundary on which we focus our attention. The system border can be real or imagined, and it can be fixed or flexible. There are three sorts of systems in thermodynamics, that is open, closed and isolated. What is isolated system? No exchange of energy or mass between an isolated system and surroundings. The universe is a solitary system. A perfect isolated system is tough to return by, but an isolated drink cooler with a lid is conceptually almost like a real isolated system. Suppose cool water, it's a tight container. Suppose there is no heat pass through and pass out. That system is called isolated system. The items inside can exchange energy with one another, which is why the drinks get cold. And therefore, the ice melts a tough, but they exchange little or no energy with the outside of the environment. So it becomes cooling for a long time. Next, closed system. Within a closed system, energy is transferred but not mass. Only energy is transferred but mass is not transferred. Closed systems include refrigerators and piston cylinder assemblies. Examples, if we put a very tightly fitted lid on the pot, it would approximate a closed system. Open system, In an open system, both mass and energy can be transferred. In a closed system, energy is transferred but not mass. But in an open system, both mass and energy can be transmitted. An open system can exchange both matter and energy that is present with its surroundings. Steam turbines and the stovetop examples would be an open system because heat and water vapor are often lost to the surrounding air. Open system in thermodynamic we can explain. An open system may be a system that has external interactions. It has an external interactions. Such interactions can take the shape of data, energy, or material transfers into or out of the system boundary, counting on the discipline which defines the concept. In contrast, a closed system, the majority of genuine thermodynamic systems are open systems that exchange heat and work with their surroundings. The matter is easily exchanged between the open system and its surroundings. This can be described simply by adding or subtracting matter. Energy is exchanged, on the other hand, can be a little more complication because energy is frequently transmitted in multiple forms of different transformations might occur throughout this process. Heat or another sort of energy is exchanged. The energy exchanged is defined in thermodynamic terms as potential energy, kinetic energy, and thermal energy. Potential energy is stored energy. Kinetic energy is energy carrying by an object while moving. However, the energy of a system always exists in one of these three states or in two states at an equivalent time. For an example, open system in thermodynamics, the earth can be recognized as an open system. In this case, world is the system and space is the surroundings. Sunlight can reach the world's surface and we can send rockets to space. Sunlight and rockets are often explained as energy and matter perspective. The first law of thermodynamics for an open system. The first law of thermodynamics is big. It deals with the entire amount of energy within the universe and it states that this total amount does not change, but differently the primary law of thermodynamics states that the energy can't be created or destroyed. It can only change shape or be transferred from the one object to a different one. This first law of thermodynamics. This law could seem quite abstract, but if we start to see examples, we can understand clearly. For example, light bulbs convert electricity into light energy, that is radiant energy. One ball hits another, the transferring kinetic energy and make the second ball to move. Plants convert energy of sunlight, that is radiant energy, into energy stored or and organic molecules. Now we can explain the difference between open system and closed system in thermodynamics. An open system is a type of thermodynamic system where the energy and matter are often exchanged with its surroundings. A closed system is a type of thermodynamic system where only the energy can be exchanged with its surroundings but not matter. Open system can exchange matter with surroundings. Open system cannot exchange. No, here open system can exchange matter with surroundings, but closed system cannot exchange matter with the surroundings. In the case of open system, the Mass of the system will vary with time. In the case of closed system, the mass of the system is constant. Open system have boundaries that are not closed. The boundary of a closed system is totally closed. The interaction between the system and their surroundings can be found everywhere in the environment. Now, in thermodynamic system, some we can explain adiabatic system. The adiabatic process is a thermodynamic process in which there is no heat transfer from in or out of the system. An adiabatic process is a reversible process with constant entropy for an ideal gas. The mathematical representation of the adiabatic process is delta Q equal to 0. That means what? There is no heat exchange from inside to outside through the surroundings. Phase. What is phase? More precisely, a phase is a region of space that is a thermodynamic system throughout the all physical properties of a material are essentially uniform. Here, this is a triple point of water. At this point, all physical properties is same here. At this point. Homogeneous thermodynamic system is defined as the one whose chemical composition and physical properties are the same in all parts of the system. Physical and chemical properties is same, then it's called homogeneous thermodynamic system. Heterogeneous system can involve more than one phase. For such a system, the thermodynamic equilibrium imposes an additional constraints. The system must also be able to chemical equilibrium. No conversion of mass occurs from one phase to another. Now, we'll explain macroscopic approach and microscopic approach of thermodynamics. First, macroscopic approach. In this approach, a certain quantity of matter is considered without taking into account the events occurring at molecular level. In other words, this approach to the thermodynamic is concerned with the gross or overall behavior of the system. This is known as a classical thermodynamics. The analysis of macroscopic system requires simple mathematical formula. The value of properties of the system are their average values. For example, consider a sample of gas in a closed container. The pressure of the gas is the average value of the pressure exerted by millions of individual molecules. That means in a closed system, pressure everywhere inside is considered as same. In order to describe a system, only a few properties are needed. For microscopic system, it's easier to understand. Microscopic approach. The approach considers that a system is made up of very large number of discrete particles known as molecules. These molecules have different velocities or energies. The value of these energies are constantly changing with time. This approach to thermodynamics, which is concerned directly with the structure of the matter, is known as statistical thermodynamics. The behavior of the system is found by using statistical method. As the number of molecules is very large, so advanced statistical and mathematical methods are needed to explain the change in the system. The properties like velocity, momentum, impulse, kinetic energy, and instruments can easily measure force of impact, etc. that describes the molecules. This is a microscopic system approach. Large number of variables are needed to describe a system, so the approach is complicated because each and every molecules can be considered to describe completely the microscopic approach of the thermodynamics. Now, what is pure substance? Is a single kind of matter that cannot be separated into other kind of matter by any physical means. A pure substance always has a definite and constant composition. A mixture is physical combination of two or more pure substances in which each substance retains its own chemical identity. Here, for example, here pure water is considered contains oxygen hydrogen molecules. Hot oxygen and hydrogen atoms in some ratios. It's called a pure water. In this pure water, no other matters is mixed with this except oxygen and hydrogen. So it's a pure substance. Itself, oxygen itself a pure substance because pure oxygen have no other matter inside. So far we discussed about different entities and kinds of thermodynamic approaches as well as systems. We have done. Please subscribe our YouTube channel.